Hi, I am Varun Joshi and welcome to day 2 of our Jenkins Basics to Production course. In this lecture, we will first discuss Git and how teams collaborate with commits, branches, and pull requests. Next, the continuous practices, continuous integration, testing, delivery, deployment, and monitoring. Then the two production styles you will often see: GitFlow based branching and trunk based branching, and how promotions flow from feature to dev to stage to production. Finally, we place Jenkins in that path as the orchestrator and reinforce the principle: build once, promote by digest. This lesson uses simple visuals and concise theory that sets up upcoming Jenkins demos. Please give it your full attention. Together with day 1, it forms the base for the rest of the course. By the end, you will understand the path from a push to a production release and exactly what Jenkins automate. Let us begin. So let's start with Git branching, the essentials for CI/CD. What exactly is Git? Git is a version control for code. Now, I want you to imagine that you are a developer and you are writing code and also testing it in your own laptop. You wrote a code, you tested it, then you performed few more changes and you tested it, then you performed few more changes, but this time the testing failed. Now you want to revert to the previous stage. How do you reach that code? Now, if you are maintaining 4 versions of the code, I do not want you to manage 4 files, 1 file for each version. We want some way via which I just have to manage 1 file, and there is some system that is ensuring that the history of important junctures in the development phase of my application are captured properly. And this is where Git comes into picture. And whatever I'm saying, the junctures of your application that you want to be saved, these are called commits. So essentially, a commit is a local snapshot of changes. For example, if you have 10 commits, you essentially have 10 local snapshots of those changes, and you can go back to the snapshot that you want to work with. That is how Git simplifies this. And you see here DVCS. This stands for distributed version control system. That is what Git is. Why are we calling it distributed? Firstly, because you have the entire code base in your laptop, and then you also have a code base in somewhere remote. Varun, why do I need the code base to be in remote? Because what you want is collaboration, reviewing, and CI. We will come to CI later, which is continuous integration. But if you want your fellow developers to collaborate with you, then you must have a centralized location from where the code can be accessed by all your team members. That is why we are saying this system is distributed. You have your changes locally, and then you also have a remote where your code base is also being managed, and anyone who wants to collaborate or review your code can do it from the remote. But Varun, what if I am doing some changes and those changes are not yet reflected in the remote? Then wouldn't the other developers who are accessing that code will be accessing a previous version? Yes, you are right. That is why you have something called push. So if you have written a code and you want your teammates to see what is the latest change that you have done in the code, then you will do a push. Send local commits to the remote. And what if a new developer has joined your team? So if you see in this diagram here, you have developer 1, and developer 2 is the person who has recently joined your team, and your team is working on application 1, which I have spelled wrong here. This is a repository for application 1 and we are calling it remote. We call this local. Whatever you are doing in your laptop is local, and whatever is happening in that remote is called remote. And that remote location, what are the possibilities for that remote location, we will see in a little while. But if developer 2 joins and developer 2 wants to see what is happening in the code base of application 1, dev 2 can perform a git clone first, and then if developer 2 wants to see the recent changes, whatever dev 1 is pushing or any other developer is pushing, then dev 2 can just perform a git pull and he will have the latest changes available in the local copy that is being maintained in his laptop. But Varun, what if developer 2 has some changes to propose? The same what dev 1 is doing, dev 2 will perform the changes and push it so that all the other developers can see the changes that are being sent to the remote by dev 2. As simple as that. This is what Git is doing for you. Now in this lecture I won't be covering the commands because we'll be doing thorough demos as we move ahead with this course. This lecture is purely conceptual because I want your foundations to be so strong that rest of the lectures are a cakewalk for you. Now the next is where to host your Git repos. Understand that when you are sending changes to your remote, you want that remote to be highly available because you cannot trust your laptops because your laptop is not highly available. If your laptop crashes, God forbid, your data is gone. Hence, you cannot just rely on your laptop when you are talking about a critical application. You have a remote and that remote must have provisions that allows high availability and they must have an SLA so that you as developers and DevOps engineers know what should you expect from the platform that is hosting your Git repository. Now application 1 repo that you see here, this is known as a repository when we are talking about Git. Now there are various options. You have GitHub, you have GitLab and Azure repos. So you can always use the functionalities provided by your cloud provider as well. But I want you to know that AWS code commit and GCP's CSR are legacy for new teams. If you are existing users, you may use it for some time, I believe, but eventually you will have to migrate if you want to leverage any new features that other competitors are providing. So you have two options here, cloud hosts, which are GitHub, GitLab, Bitbucket, and there are more, of course. Then there are provider suites, which only Azure is there, which is now providing Azure repos. Then there is self-hosted. If you do not want a public service like GitHub, GitLab, you can have it privately. You can create a GitLab CE or EE, Git, Gerrit. All these allow you to use self-hosted repository hosting platforms. I want you to understand one thing. If you are self-hosting, you must ensure that your solution is highly available. Now let's talk about what are branches in Git. A named line of work. If you see here, there is a main line, and main line is the one that has all your code right now. Let's assume that. And then if you want to introduce a new feature in your application, for example, if I'm managing a banking application and I want to add a new feature which will allow users to top up their loan, then what I will do is I will create a feature branch, and that feature branch I will name loan. Now I want you to know from this stage itself that you can have multiple feature branches. If you are introducing multiple features, you can have multiple feature branches, and in each feature branch there could be multiple developers working. So broaden your imagination from this stage itself so that whatever we learn fits in. And main is equal to the source of truth. So if I go to my GitHub repository, I'm going to my browser here, and you see we have this Jenkins Basics to Production GitHub notes, where I am capturing all the notes for this lecture. And you see I have a branch here that is named main. Now some call it main, some call it master, but typically you will see it main, and often this name persists. You do not rename this to something else just for consistency's sake. And then you can create multiple branches if you have a requirement for that. When you are working with a production grade application, you will often see there are multiple feature branches created based on your requirement. And again, do not limit your imagination. I only have main here. There are certain implementations where you will see there is a dev branch, there is a stage branch, there is a release branch, there is a prod branch, and so on. It is what your application architect decides, and then based on that you work on that project. And again, you could see multiple branches based on specific applications. Then what is a PR? What is an MR? Firstly, they both mean the same thing. There is a lot of confusion. PR is pull request, MR is merge request, and I prefer the term merge request, but GitHub is more popular, hence PR term is more popular. But I like MR more because it conveys the message within its full form itself, that what it is doing. What is a merge request doing? For example, you were working on your feature branch here, you created your feature branch. From this stage, you performed your changes, you performed your commits. This was your first commit, then this was your second commit, and then you performed your respective commits, and then you decided, I want this feature to get merged with the main branch, because now my application is ready to test whatever feature I was working on with the main application. So you perform a merge, because I want you to understand at this stage itself that feature branch does not hold the full code. Your full code right now is in the main branch. You cannot perform end-to-end testing of this until and unless you merge it with your main branch. And once that merge is performed, then you can test the entire application along with the feature that you have recently introduced. Now, here is a catch. Should I be allowed to perform a merge in the main without any tests? No, you should not be allowed. Hence, you have the concept of protected branches and status checks. So what happens is, whenever I say a branch is protected, there are certain rules in that branch, and a rule that you would often see is a push is not allowed to these sort of branches. I cannot directly perform a git push in the main branch, because main branch has a rule that prohibits anyone to perform a push or a force push. Only PRs are allowed, or only MRs are allowed. And even before the merge is allowed, there are certain checks that are run to ensure whatever I am doing, whatever I am introducing in the main branch will not break the existing functionality of the main branch. If my changes were to disrupt the existing application, then what good are my changes? And this is the main branch that caters my production. I do not want anyone to walk in and merge to my main until and unless I perform certain checks. That's why you see here PRs only, no direct pushes, requires reviews. Now, in case you are deploying to your production, then you might want that someone manually reviews it. And I use the word might, and you will learn as we progress with this course why I am saying you might need a manual review here. Last is CI must pass and be up to date. Now imagine a scenario with me. So here is my feature loan. Let's say developer 1 was working here. Developer 1 opened a PR, and then there is a developer 2 who was working in, let's say, some another feature. And developer 2 also raised a PR because she was also done with her work. But what happens is, let's say her PR got executed first because she was making a small change, and then this branch had a new commit, and that commit is here. Let's say I'll copy this, I'll paste this. There is a new commit. So from my PR's perspective, I am not dealing with the latest commit of the main. Hence, this is not a valid design, which is why I'm saying here CI must pass and be up to date. Branch must be up to date. So whatever I am doing should be done with the latest commit in main, and latest commit that is successful, because this merge will only happen when all the CI checks will be performed. And if you are hazy about these things, do not worry. I have a diagram later in this section which will help you solidify these concepts. Just create a mental picture right now. Whatever we are discussing, we will be discussing it diagrammatically as I progress with this lecture. Now, last is, why are we studying Git if the topic of the lecture is CI CD? Firstly, whenever there is a push or a PR, there is a CI build that starts, and we will dissect this, why this matters, as we look into the nitties and gritties of the CI process. CI is continuous integration. Status gates the merge. And what is this status? This status is status checks. I will only allow this PR to be approved when my PR status is green. And what all things does the PR status depend? It could depend on whether the CI run was successful, or if there is a specific file in a specific location. There could be hundreds of permutations and combinations based on which I will approve this PR. Lastly, CD promotes the build artifacts to dev stage prod, as you might understand. So there are two terms, CI and CD, and in the subsequent section we will be zooming into these terms. I hope you have a good understanding of how Git fits into the larger picture. If not, do not worry, we will learn more as we progress with this lecture. So I'll scroll down, and this is what I want to discuss now. CI and CD, continuous integration, and CD is continuous delivery or deployment. But I also want to discuss two more terms, that are continuous testing and continuous monitoring. These two also work from start to end. There is also continuous security, because we want everything that we are doing is secure. So whenever we are doing certain steps in CT, we also integrate certain security level checks, so that the application that we are deploying using the pipeline is secure to run in production. So with that information, let's start this discussion of continuous practices in DevOps. 10,000 foot overview. I want you to understand these things at a very high level so that rest of the lecture is easy to understand. First is continuous integration. The first is build and test every push PR automatically. Now, right away, I want you to think of two things. When I'm saying push and PR, that implies I'm talking about a Git repository, right? And when I'm talking about build and test, I am talking about the build stage. And if you remember, while we were discussing the build stage in our previous lecture, we know what happens in the build stage. If I talk about interpreted languages and you want to deploy your code onto, let's say, a containerized environment, then your build will be a two-step process. First, you will be compiling the language. Let's say if it is Java, you will be, let's say, creating an artifact in .jar format, and then you will be creating a container image out of that. So the build is essentially a two-step process. In interpreted, it is just a one-step process. You take the code and you create your container image, and then there are plenty of other things that are performed that are related to security. So when I talk about continuous integration, I want you to understand that whatever happens with your Git repository and whatever happens in the building stage is called continuous integration. The question then becomes why we are calling it continuous integration, because every change that you are performing in your Git repository is automatically built, tested, and integrated the moment it is shared. So understand these points. Second is fast checks enforce merge protection on the branch. Now it is not that everything that is pushed will be built. There will be certain parameters, certain rules that will be in place. Only if those rules are met, only then the build will start. So we will see what those rules are later in this section. And as I just told you, compiling, unit testing, quick security dependency scans, all of these things will happen in the continuous integration stage itself. What are the tools that are used in this stage? Jenkins, GitHub Actions, GitLab CI. Do not worry, once we finish this section, I'll tell you how the story is staged from CI to CM. Then we have continuous testing. Now I want you to clearly know that testing happens across the pipeline, and we know these are just logical constructs. These could be happening at all stages. If I talk about monitoring, monitoring happens from start to finish. Can you say that monitoring only happens in this part of the pipeline? No. And same applies for testing and security, and we saw that in day one as well. Whenever we are talking about a continuous design, testing, security, automation, monitoring, all these things, they are happening on every stage of the pipeline, and hence at every phase of SDLC. Of course, you cannot perform monitoring when it comes to requirement gathering. You cannot perform security at this stage. But again, all these things, all these logical constructs are kept in mind whenever we are discussing any phase of the SDLC. Then let's come back here. And the next point is adds integration, API, UI, performance, security suites. Now at this stage itself, I want you to know that testing can be thought of as two-phased process. Okay, first phase is pre-deploy, when you have your artifact with you. Your artifact could be the container image or your .jar file or any other artifact that results from your build. Firstly, you want means to test that artifact. Then when your application runs using that artifact post you have done the deployment, you want that also be tested. So first you are checking the static things, and then you are checking the things that are running. So when I talk about testing, you have both of these. You have SAST when I talk about anything pre-deploy, and post-deploy you have DAST and other related tests. For example, you cannot perform integration, API, UI performance tests until and unless the application is running. But security suites, the vulnerabilities, you can start doing these sort of tests from the very beginning itself, from the point where developer is writing the code, because you know, like we discussed in our day one's lecture, that there are plugins that are in your IDEs that are ensuring the code that you are writing is not vulnerable, or it is not using any dependencies that possess vulnerabilities. So runs pre-merge, pre-deploy and post-deploy. Last is there are different tools that could be used to do these things: JUnit, TestNG, Cypress, JMeter, and so on. There are plenty more. You will learn about all these as we progress with this course. Then I talk about continuous delivery. And before I start this discussion, I want to differentiate between continuous deployment and continuous delivery. Now, continuous delivery is anything that requires manual approval before deploying. So when you think about continuous delivery, think of a person that is there to approve, human approvals and gates. So human intervention is there before deployment whenever we are talking about continuous delivery. Then what is continuous deployment? When there is no human intervention, that is, no human is approving anything before deployment. Now you must be thinking, but Varun, that's a bad thing. No, that's not a bad thing. If there are no humans involved, then you must ensure that your CI, your testing and your deployments in staging and development are so well rehearsed that you do not require anyone to approve before your code is deployed onto production. So again, when I talk about continuous deployment, auto deploys to prod. Again, prod is the keyword. If you are auto deploying to staging or you are auto deploying to development, it is not continuous deployment. Continuous deployment implies when you are deploying the code without manual intervention in production environment. I hope that clarifies any doubts that you had between delivery and deployment. So let's read the pointers now. Keep main always deployable with versioned artifact. That makes sense. And I told you this briefly in the previous stage. Your main should only hold the code that can be easily deployed. Then promote the same artifact across environments. Important point. So for example, in development stage, if I have a build that resulted in a container image, then you should be using the same container image in the staging and in the prod environment. So essentially, you did the build of the container image only once, and then the same build was promoted onto staging, then promoted onto production. So I want you to keep these definitions in mind. And again, if anything is not making sense right now, do not worry. We have a diagrammatic section where we'll understand all these things step by step. Next is human approval gates before production, that we have already discussed. There are tools that will help you with this: Jenkins pipelines, GitHub Actions, GitLab CI CD. And then if I talk about continuous deployment, there is auto deploy to prod when all checks pass. This is, we have discussed. Progressive delivery. You have to choose what is your deployment strategy, whether you want to use canary, whether it is blue, green, feature flags, and so on. And as we progress, I'll discuss all these three briefly. Then there is a rapid rollback on failed health signals. You would want to roll back if something goes bad, and there must be processes in place that will help you do the same. There are different tools that can be used with continuous deployment. And those tools are Argo CD, Flux, Spinnaker, and there could be more. Argo CD is a popular tool which I will also cover in my channel. Maybe the next course will be on Argo CD itself. Then lastly, I want to discuss continuous monitoring. Now we know observability has three pillars. There is metrics, logs, and traces. And observability can be thought of from two perspectives. There is an infrastructure perspective where your Kubernetes clusters, your servers, all these things come into picture. And then there is application perspective. Now application perspective will cover anything that is application specific, that is application performance monitoring is there from applications perspective. So you would want to have all these three things so that you can properly judge the health of your application and your infrastructure. Now we discussed this in detail in our Kubernetes observability section. I will link that lecture as well. If you want to know deeper about observability, then you can definitely watch that lecture. So you should be able to visualize health of your application and your infrastructure, detect regressions, trigger incident response. So this is part of your ITSM process. You should have these things in place to ensure that your application and infrastructure is in good health. Tools, there is Prometheus, Grafana, Elasticstack, Datadog, New Relic. There are many tools, and then there are offerings from cloud providers as well. Azure has Azure Monitor, Logs, AWS has the CloudWatch suite, X-Ray, and so on. All these things can be used for APM and also for infrastructure observability. Now, if I have to stitch this entire story, CI proves a change is safe to merge. We know that, and we will dissect this more as we progress. CT widens the safety net because that is where the testing is being performed. CD keeps releases always ready. CDP, that is continuous deployment, ships automatically. Continuous monitoring watches everything and informs the next change. Now, why and what of Jenkins? What is Jenkins doing here? Jenkins is your orchestrator. It is an automation server which will do whatever you ask Jenkins to do. If you ask Jenkins to pick code from location A, paste it to location B, it will do that for you as well. But we leverage Jenkins with CI/CD, and this entire lecture will tell you how. So as we progress, we will see where Jenkins fit and why, in my opinion, this tool must be learned by any aspiring CI/CD engineer. So let's come below. Before I start discussing the pipeline, I want to discuss branching strategies, and I want you to know that we are not talking about environments here. Environments as in, we are not talking about your development environment or your prod environment. Here we are talking about branches. So when I say GitFlow based CI/CD, it works on the premise of environment branches. Now, environment branches as in, there could be multiple feature branches, and there will be a dev branch, a stage branch, and a prod branch. And as you understand, the code will be promoted. First, the developer will do the changes in the feature branch, then a PR will be created to the dev branch, and from dev branch, the code will be promoted to the stage branch, and from stage branch the code will be promoted to the prod branch. And similarly, codes from these respective branches will be deployed to the respective environments. For example, code from the prod branch will be deployed onto the prod environment. Code from the dev branch will be deployed onto the dev environment. So keep this in mind. The second one is trunk based. Now, trunk based is, you have multiple feature branches, but there is only one main branch, and that main branch is the single source of truth. So what happens is, there are multiple checks which allows you to deploy code from that one single main branch to different environments. So you can use that single branch to deploy the code onto the dev environment, to the stage environment, and to the prod environment. But Varun, how does it help? Isn't there a rule of thumb that I can use? The rule of thumb is, if your changes are very frequent, so if I talk about a busy application that sees 100 changes per day, 50 changes per day, then they would probably be using this approach, because this is used when you want to fast track everything. And GitFlow is typically used when you have a stable application. Maybe you are performing changes once a week or twice a week and so on. And again, these things are not written in stone. You could be starting with this strategy even when you are performing change once a week or once a month. It is dependent on application, and these are not the only two strategies, branching strategies, that you would be using. You would see others as well, but 90-95% of the projects would be using these two branching strategies, which is why I want to discuss these. And again, once you understand these two, rest of the branching strategies will become a cakewalk for you. So let's quickly read these points. Multiple long-lived environment branches, we have just learned that. Dev, stage, prod lines, and then you have feature branches. CI triggers PR between environment branches. I just told you that in the introduction itself. And let's contrast whatever we have read with trunk based. Single trunk main as is the source of truth, short-lived feature branches only, and then you have the main branch where a PR is created. CI triggers PRs into main merge result. That's fine. Build only happens once. This is interesting. Okay, so when you are using multiple branches, then also the artifact that is generated, artifact as in the container image or the jar file or both, they are only generated once in both of these scenarios. And I do not want to explain this to you right now. We'll explain this in the diagram section. Governance, strong reviews, approvals, and traceability. Now, since we are using different branches for different purposes, for different environments, it is self-explanatory that this approach has stringent controls and is good when it comes to traceability. But having said that, do not think of trunk based as any less. The checks are lean, but again, it depends on what you configure it to have. So for example, maybe when you are deploying changes to dev, you do not have those many checks, but when it comes to prod, you have a checklist of 150 checks that must be performed. So that makes trunk based really secure. So it depends on how you have configured your CI server to interact with these branches, or how you have configured your CI server to perform the checks. What all tools have you integrated with your automation server, which will ensure how and when the changes are deployed onto your production, staging, and dev workload. So the control is in your hands. How you configure will determine what level of governance each of these approach will have. If you do not have any governance in GitFlow based, then again, this will create chaos. It's not that if you use this, there will be no chaos, because unmanaged pipelines are a nightmare for a DevOps engineer. The next point is trade-off: more merges, branch drift risk. Trade-off is needs small PRs, solid tests, and we'll see this in the diagram. Use cases: regulated apps, release trains. Use cases: microservices, SaaS, rapid delivery. Now here is the mental note. This is important. The first line is important. In both styles, you build once and promote the same artifact. So the artifact is not generated 3 times for different environments. It is only generated once. Then there is GitFlow, uses environment branches. Promotions are PRs between branches, dev, stage, prod, that deploys that artifact. Trunk based keeps all the code in the main branch. Promotions update environment configurations. For example, there will be a different configuration for dev and there will be different configuration for stage and prod, so on, to deploy that artifact. No environment branch merges. So there is only one branch main, that is the source of truth. Then there are multiple feature branches. Now let's discuss GitFlow based CI/CD environment branches. So we will first be discussing GitFlow, where we have three branches like I talked: dev, stage, and prod, and we have multiple feature branches. Here first I'm going to show you the transition from feature to dev, and then in the next diagram we'll see how the artifacts or how the code gets promoted from dev to stage. Firstly, flow will be feature first, then to dev, then to stage, then to prod. This is I'm calling a beginner's flow because I have not added all the bells and whistles here. There are many more functionality that could be leveraged, but I promise you, if you understand this flow, whatever flows that we are discussing in today's lecture, any CI/CD pipeline, and from after this lecture itself, you will be able to make sense of those, because these concepts are the foundations. So let's see what we have here. We have a developer here. Developer has written the code, developer commits. Now commit happens in the local branch, and then when you do the push, it is only then the code goes to the remote. So developer performs a push to the feature top up loan. And again, like I discussed before, I am calling this top up loan because let's say this developer is working on a feature that will allow users to top up on their loan. For example, if they have a 2 lakh loan right now, they can increase that to 2.5 lakhs. Second step is opens PR to dev. Again, I told you that this developer cannot directly push to dev because dev branch is a protected branch, and you see a lock symbol here. Again, I want you to clearly know that all the feature branches that gets created, these are the branches where your developers would work. So they will be able to push directly onto only these branches, and rest of the branches they will not be able to directly push because they are protected branches. Now as soon as a PR is open to dev, a CI runs. Now understand, we are not saying that the PR gets approved or whatever was here is merged onto the dev. We are saying a CI runs, and this is your CI pipeline. And here are the rules that decide when can this change be merged with dev. Firstly, this is a protected branch. It says that PRs only, no direct commits. This part we understand. And then there is a second point that says require status checks to pass. And here our status check is only one, that is CI must be green. So what I am saying is, when I run this CI pipeline, only when this CI pipeline gets successfully executed and I have a green here, only then merge PR into dev. If this fails, then tell the developer that fix the errors that you see in the logs and then repush, and the CI will rerun. So we are clearly saying, do not approve the PR until and unless the CI is green. And if the CI is green, then merge the changes onto dev. So let's see what is happening. Now here, what happens is CI tests dev plus feature. Dev is unchanged. So what this will do is, it will take the changes that the feature branch has, and it will take the latest commit from the dev and run this CI pipeline. If I want to know how this feature will impact my application, or how this feature will integrate with my application, or whatever I have coded, will it at first integrate with the app code or not, I need to test this with the latest commit in the dev, because that is the main application. So when I do that, what this CI will do is, it will only perform the changes on the feature, plus it will take the the code that is in the dev branch, and dev remains unchanged. Now we know what CI pipeline will do. It will check out first from the GitHub repository, it will check out the code, and then it will build and test it. I want you to know that Jenkins is orchestrating all of these. You will be configuring how to reach your GitHub repository in Jenkins. You will be configuring what tests to perform, what builds to perform in your Jenkins. You will be defining where to deploy in your Jenkins. So Jenkins is the orchestrator that will make everything happen for you. So in the third step, we perform this, then the status of the PR. It will either be green or it will be red. If it is red, let's say if the build fails because of XYZ error, then the merge will be blocked and the developer will have to fix the code, repush and rerun the CI. If it succeeds, we will do the merge and we are also deploying it onto our compute. Now I want you to know this compute could be your Kubernetes cluster, this compute could be your virtual machine, or this compute could be serverless. I am saying all these three here because at this stage of your learning, I do not want to bombard you, but in next section, in the next diagram, we will make this specific to Kubernetes because it will involve more nuts and bolts. Again, so let's read what is happening. CI runs on the PR, tests dev plus feature. Green enables the merge, red blocks it until you push a fix. So until and unless this is green, the PR will not be merged into dev. After merge, you may auto deploy to the dev environment. Now I want to introduce something that will help you in designing and thinking in a better way. When I talk about dev environment, you can use a blue color there. If I talk about stage, you can use yellow there because staging environment denotes pre-prod and it is like handle with care. And then prod is typically denoted by green color, which implies success, stable and live. So if there are any errors or something, that is denoted by red like you see here. So keep these colors in mind. So if you are creating any diagrams, use blue for dev, amber or yellow for stage and green for prod. Now that we have understood this step, let's see what happens when we try to go from dev to stage with the help of next diagram. Okay, now I am calling this a promotion PR. Here we are moving from dev to stage. Deploy before merge flow, and I will explain what this means in a little while. And like I told you in the previous section that we will now be using a Kubernetes cluster, hence you only see a Kubernetes cluster here. And now let's see what is happening in this diagram. So first is what happened in the dev build. So I oversimplified this by saying that you can deploy into any environment, and that is how you would be handling projects. There could be applications which will be deployed onto virtual machines. There will be applications that will be deployed onto serverless and so on to Kubernetes as well. But now we will focus on a Kubernetes cluster. If this were done for an application that is supposed to be containerized, then let's see what all steps would be performed in the dev state. So here I am saying what happened in dev build. So the first is build once and push. So what would have happened in the build phase is once the application artifact was received, let's say it was a Java application, and if you are not understanding these terms, go and watch day one. Okay, so you have .jar and based on .jar you created a container image and you push that onto an image registry. Now that image registry could be GitHub container registry, which I am using, or it could be your cloud native solution. So what we have done is understand that we are calling this repository banking loans, and then we have something like this here. And what are these? Now typically when you see the tagging convention here, this is the commit ID. So commit ID is whatever you would have received here, that commit ID, along with the version of the application. So let's say this was version 1.4.3 of the application, hence I have written both of these, the commit ID and the version of the application. Another point is capture, digest, immutable. Now I want you to clearly know that if you have not enabled tag immutability in your image registry, then anyone can push another image with the same tag and it will overwrite your existing image, and that is not something you want. And even if you have tag immutability, it is still recommended that you use image digests when you want to pull a certain image. Varun, what do you mean by that? If you see here, I just want you to concentrate on this point right now. I am saying the image is this @SHA and there is an image digest here. So in production implementations, in enterprise implementations, you will always be using digests when it comes to container images. You will not be using tags in enterprise production environments. Now why is that? The reason number one is these image digests, or simply called digests, are immutable. You cannot change them, and I want to demonstrate this to you. I'll go to my iterm, and if I press ls, you see I have a docker file here in day 2, and if I cat on this, and it's a simple docker file, we are saying just from this and echo hello from image. Now let's do one thing, let's make an image out of it. So I will write docker build -t. I will call this cloud with varjosh so that I can quickly push it /, let's call it loans, and here let's say the commit ID was 777 YGT. Let's say this is the commit ID. Let's add 2 more digits here. So this is the commit ID. Now I'll do one more thing here. I'll add -t, and then I will write here version 1.44.3, let's say. And then I will again add -t. I will paste that again, and this time I will write v1.44.3, and then I will add a dot because I want to tell that my docker file is present in the current working directory, and this is my build context. I want you to clearly know that I am creating a single image here, and I am adding 3 tags to that image. Tag number 1 is of my commit hash, tag number 2 is of my commit hash along with the version of the application, and then the third tag should just be of the version of the application. Let me just quickly correct this. So I will remove this, and the third tag is of just the version of the application. But Varun, why are you creating 3 tags? So let's understand this. When I talk about version tags, these are used by product QA and support so that they can map incidents to a release quickly. So these are great for change logs and dashboards. If I talk about, let's say, commit tag, which you see here, this one is a commit tag because here is the commit ID. Then these are used by developers and SREs so that they can map an image to the exact commit. So if you see this, you exactly know which commit was done to create this version of application, because you would see what changes were made to the code and the entire code base when you see that commit. Now what is this combined tag used for? Now combined tag is best for both in one glance. You get to know the version as well and you get to know the commit ID as well. But in my opinion, creating this tag is of paramount importance because you see both the things at one place, version at one place and also the commit ID, so that you can directly check what was the code like when you were in this version of application because you have the commit ID with you. Now let's get to the crux of it and build this image. I'll press enter and this has started building the image and it will tag this as well. So if I run docker images, I see that there are 3 tags associated with my image. The point I want you to concentrate on is the image ID. So understand the contents of all these tags is the same, hence the image ID that you see is also the same. Now image ID is not same as digest. You will only get the image digest when you push this to your image registry. So my image registry here is Docker Hub. So let me push this to Docker Hub so that I can show you the image digest as well. So I'll write docker push. I will write -a. I'll tell you what -a will do. And here I will write cloud with varjosh and it is loans. Now what this will do is this will push all the tags to Docker Hub. I'll press enter and this has started doing its job, and along with this command will also show me what is the image digest. So let's wait for that. And you see all these digests are same, and if you want to look at it, docker images, I'm forgetting, it is, hold on, digest docker image -h. I want to grep for digest, sorry, docker images -h. Yeah, it is digests, hold on, docker images digests, and here I can name my image cloud with varjosh loans. I want to check it for this. So if you see, the digest is exactly the same. So even if someone changes these tags, if I do not have, let's say, tag immutability enabled, then this digest will always remain the same. And this digest is same because all these tags, they are holding the same content. Even if there is a slight change in the image, this digest will change. So understand this point. In production scenarios, you will always be using digest to pull the images. So let's go back to our browser and I want to show this to you in the Docker Hub console as well. So I'll refresh this. I'm in the repositories. I'm in my cloud with varjosh account and you see the loans is here. I'll click on this and if I go to tags, you see I have 3 tags. Version tag, there is the commit tag, and then I have a combined tag here. But all of these, they have the same digest. And if I click on this, I will get to see the entire digest. And this is the format of the digest. If I write this and then @ this digest, then it will pull this image itself. So I hope this point is understood. Now capture the digest, publish manifest.json. Varun, why are we doing this? So in the build stage, you are building an image. I want you to understand, and this happened in the dev build, okay? In the dev build. Now we are just promoting dev to stage. Now in the dev build, understand that we built an image and our registry could be holding multiple images. How do we tell the deployment part of our CI/CD that you have to use this image for deployment? There must be a file which will have all the information that my Jenkins can use to deploy my application, and that information can be provided using a file. And that is why in the dev stage itself, when the build happened and our Jenkins, which is our CI/CD, pushed the container image to our image registry, which is GHCR in our example, it created this file for us. Now this file can be created anywhere. It could be in your S3 bucket, it could be in a GitHub repository, or it could be part of the PR request. But I want you to know that your Jenkins server should have access to that file, because once Jenkins server have access to this file, Jenkins would know what to deploy. Because like I said, there will be plethora of images in your image registry which could have multiple digests, but we want to aim for the digest that we are looking for. And here you see I have added all this information, the time tags, the all the tags, commit, sha, version, digest, and the repository. So I hope this makes sense to you. All this happened in the dev stage itself, in this stage itself, but I did not want to complicate things. That is why I didn't show these things here. So now let's see what actually happens. So first is opens promotion PR to stage. We are calling this a promotion PR. There we were just calling it a PR. Mind the nuances, look for the nuances. Opens promotional PR to stage. Now as soon as the PR is opened, CI runs. It is like before itself. Now when will the deployment happen? So let's see what are the branch protection rules and what should happen for the code to merge successfully. When will the PR be approved? So firstly, PR only, no direct pushes. Second is dev run green for the promoted commit. So this pipeline should have been successful. Only then you can move that artifact or that code to the staging stage. So that's what we are saying. Dev run green for the promoted commit. Up to date with base include latest stage. And I told you this. The stage should be up to date. Like we discussed before, there should be no commits that were performed after this PR request was created in the stage branch. Fourth is require these statuses to pass. What is pre-flight? Pre-flights are part of the CI itself. Then there is pre-flight config, deploy to stage, pre-flight manifest, as in this manifest must exist. So CI is ensuring we will only merge this when there is a pre-flight manifest, and this is the manifest. Pre-flight config. What is pre-flight config? It is these things. For example, Helm lint should be successful, Helm template should be successful. All these are performed in the CI stage itself, and only when all these are successful, then the PR is merged. Then we are saying deploy to stage, stage smoke, stage integration. All these tests we have discussed before. Lastly, once all these are successful, then I want at least one person to review this. It could be your TL, it could be the QA team, or it could be the owner. Understand, this manual review process is optional. Some might not have this. Now, I am not sure whether you have noticed it or not, but here we have the deployment step before the PR merges. And when we were discussing feature to dev flow, we had this at the very last. Now, first, I want to explain you why this is the case. When I'm talking about staging, staging is like pre-prod. Whatever is there in pre-prod, you want those things to be extremely perfect. You want the deployment to be successful. What if the CI pipeline succeeds, but the deployment failed and the merge was performed? We don't want that. We want to only perform the merge when the deployment is also successful. So it makes sense because staging is pre-prod, and production, of course, will adhere to the same design. So only perform the merge once continuous integration is green and the CD is also green, that is continuous deployment or delivery. Both of these things must be green for my merge PR into stage to be successful. But Varun, why is it like this when it comes to feature branch? Firstly, I want you to know there is something called fast feedback. The primary goal of the feature to DevFlow is to get new code from multiple developers integrated into a single shared environment as quickly as possible. Now, waiting for a full deployment to succeed before merging here would create a merge queue. If deployment fails, the PR stays open, because understand, there are multiple developers who are working in their respective feature branches, blocking the next developer who wants to merge their code. Hence, in this scenario, you would often see that the merge is performed before the deployment stage, because again, development is there to perform testing left, right and center. There will be multiple PRs that will be raised for dev branch compared to dev to stage or stage to prod. Another thing is catching failures early. It's meant to be a place where things might break, so it's okay if my deployment fails after the merge, as long as the developer who caused that havoc is ready to fix those things. So here the agenda is fail fast and recover faster. That's the reason why you do deployment at the very last. Okay, now let's continue with this discussion. Now, if I talk about CI pipeline, here we are doing three things: pre-flight, deploy, and post-deploy. So whenever CI pipeline is created, the first step is pre-flight, and we know what are the pre-flight steps. Manifest.json should be reachable. That is here. Now it could be hosted in different platforms, like I told you, S3, GitHub, or it could be also part of your PR's description. And I want you to know that whenever you create a PR, provide proper description in your PRs. Okay, what this will do, what is the expectation, and all of these things. Second is image must be pullable by digest. So all these things CI will verify. Config renders cleanly. Now you could be using Helm, you could be using Customize, so you would apply those testings in the CI phase itself, because you do not want those things to fail when you are in deployment stage. You want to fail fast if at all you are supposed to fail. Here we are saying Helm upgrade install loans. We are upgrading this, and you see what are the variables that we have defined. Variables are defined from the manifest.json. Here we are using jQuery. If you have seen the JSON path lecture in our Kubernetes series, then this will make sense to you. We are querying this manifest and finding what is the value of image. The value of image is this. What is the value of digest? The value of digest is this. And based on this, the whole image along with the digest is formulated, and you have a deployment. So these things are checked pre-flight. Now the deploy phase. Refer details from manifest.json. All the details are here. Deploy to stage by digest with stage config only. And what is the stage config? That will be saved in your values-stage.yaml. So all things are connected. Now I want you to concentrate on the parenthesis as well. No rebuild. So it is not that staging will have its own rebuild and then prod will have its own rebuild. Nothing like that. Whatever was built in this stage itself, and that same artifact is being promoted to stage and being promoted to prod. So image is this one by digest, not tag. I'm stressing on this point. Use digests in enterprise production grade implementations. Then next is post deploy, only things that need a live stage. And I discussed this briefly. There are certain tests that needs to be performed in the live running environment, and that can only be performed once the deployment is done. So here the smoke test is quickly checking whether the website is accessible, you are able to log in, you are able to click on the tabs or not. All these things are part of post deploy checks, and configuring whether your readiness probes, your liveness probes, and all these things are successful, and they check your application paths, application ports. All of these things can be checked in this stage. And then small integration text, 1 2 happy paths. So if you are applying for a loan, are you able to proceed? That's one happy path. Second happy path could be if you want to download your statement, are you able to do that? That's second happy path. And there could be several happy paths that you want to verify when you are testing this. Small integration as in how are two parts of your application behaving. All these things will be performed post deploy. What if there is a failure? In that case, you should be able to rollback, Helm rollback, or whatever you are using, you should be able to roll back. And once the rollback is successful, you again fix it on dev, build a new digest, and re-promote. And then finally, let's say all of these things succeeded, the CI succeeded properly, then the deployment will be done. And only when the deployment is successful, the PR status will be green and the merge will be performed. So whatever was in dev stage is now part of your staging code. And then if something is wrong, the merge is blocked. You fix in dev, new digest, re-promote, and that's the entire process you follow. Now let's see what I want to discuss next. So next is stage to prod versus dev to stage. I want you to know that when you are dealing with stage and prod environments, then when you talk about stage part is heavier post deploy. Okay, but when you have a production application running, it is more heavier on the pre-deploy stages. So pre-deploy is you will have more checks in your CI when it comes to prod when compared with stage, because in production you do not want to perform so many tests in your running application, because staging is pre-prod. These environments in enterprise applications are similar if not same. So whatever configuration is there in your staging environment is also there in the production environment. So when you have a running application, it is suggested in prod you mellow down your testing, because you have already performed all that testing in your staging stage. But have pre-deploy tests. They are more when I talk about the prod stage. So I only wanted to talk about this when it comes to the promotion from stage to prod. Rest I will quickly read it for you, but they are pretty much similar if not same of what we discussed just now. Promotion PR references stage proven digest, we know, plus commit and version. We have seen this. No rebuilds, promote the same artifact by digest. So whatever container image was created in the dev is used in stage and also in prod. Third is prod branch stricter. PRs only, approvals config validated. For example, here we only had one manual approver. In the stage to prod part, you could have 2 or 3 manual approvers. One your team lead, another your QA lead, and then there could be one that is your change manager. So all these things must be in place. CI pre-flights. Manifest reachable, digest pullable, both of these we have already discussed. Then here is flags off. So whenever you talk about deploying an application or upgrading an application, there are two perspectives. There is an infrastructure perspective and then there is an application perspective. Now we must have means in both of these to control how the upgrade is performed. So when I talk about a production application, you would, let's say you are using canary based approach for your upgrades. Now canary is you gradually roll out the changes. For example, first only for 20% of the users, then 60% of the users, and then let's say 100% of the users. So this is how canary is performed. And at infrastructure layer, you could be performing these at your load balancer controller level, or you could be having your service mesh, which is helping you with canaries, and eventually your deployments will be handling the traffic. So that is how you will cater it from an infrastructure perspective. But how about application? Now, when I talk about infrastructure, you cannot control how the new feature is behaving. From infrastructure, you can control the entire application. That entire application will only receive 20% of the traffic first. The upgraded version will receive only 20% of the traffic, and then 60, and then 100, and so on, whatever your permutation and combination is. But when it comes to that specific new feature, you do not have any control over it from an infrastructure perspective. But when I talk about applications, modern applications, what they will do is they will typically release the new version of the application with the flags off. Now, flags off, what will this do is this will disable the new feature when you first deploy the application. So first, they will test how the application is behaving with that feature disabled. If the application works fine, only then the flags are enabled, and these flags are still enabled in a staggered way. So first only 30% of the users will be able to use that feature, then another 50%, then 100%, and so on. This can differ application to application, organization to organization. But what I want you to understand is these things can be controlled from both infrastructure and application level. But from infrastructure, you cater to the entire application, but application teams can do this per feature level as well. So that is what flags off mean. So when you are deploying application onto production, you will typically have flags off, but in staging, these flags are often on at the beginning itself. And again, you can test various permutations and combinations in staging as well, because these things are specific to project application organization. The next is cautious rollout. In cautious rollout, you have canaries. Canaries we have already discussed. Blue green is you have two environments and you deploy to the new environment, and the previous environment can then be used to deploy the next version of the application. So you maintain two full versions of your infrastructure. So for example, if you are using Kubernetes, then you will have two Kubernetes clusters. When you upgrade your application, you will upgrade that onto the second Kubernetes cluster, and your traffic, your users will be served from the second Kubernetes cluster. And once there is another release of your application, then you would again be using cluster 1 to run your upgraded version. So this continues. This approach is costly, but if your availability requirements are like that, then you can also use blue green. Canaries is the one which is most popular. In canaries, the shift is gradual. So first 10% of the users will be served with the new version, then 30, then 50, then 100. Now what I am saying is guarded by SLOs. The strategy in both stage and prod will be same. For example, the strategy in stage will still be canary, but in staging you would be deploying it for 40% of the users, then 60%, and then 100%. But in production, you could first be only deploying for 10% of the users, 20%, then 50, then 60, then 80, then 100. So you are more conservative with your percentages when it comes to production. Post deploy checks, health, synthetics, brief, dwell period, this we have already discussed. Responsibility split, and we saw this at the very first. Stage is heavier post deploy, prod is heavier pre deploy. If signal fails, auto rollback, fix fast, and re-promote. So this is all there was to GitFlow based CI CD. Now let's see what happens when you are dealing with trunk based CI CD feature. As we understand from our previous discussions, that in this you have main branch, that is your source of truth, and then you have multiple feature branches where your developers will be working. I want you to know here the source of truth is only main. That is why you see the main branch is being used to deploy onto different environments: dev in blue, yellow in stage, and green in prod. So let's see how this works. So developer commits and pushes. As soon as the push happens, PR is opened and then CI runs. As we know, here is the CI. CI will be performing the checkout, build and test, and based on the results of this PR, a merge will happen. And you can see here what all things are performed by our CI. Its build succeeds, unit tests are performed, lint format clean, quick security scans, up to date with mains. Now I have deliberately chosen different level of things when it comes to CI, but you could be doing all these in other diagrams as well. But I wanted to give you what all are your options so that you understand in a better way. Then we have a PR stage. Here is the result. So if it is green, if all these succeed, build, unit, lint, security scans, up to date, the build succeeds, only then the merge will happen. And once the merge happens on the main, then you can publish it. Understand that the publishing part is called as continuous delivery, continuous deployment if there are no approvals that are taken in this stage. Now I want to explain post merge actions on the main. Build package once, publish image plus digest, example this, also publish manifest. Now I want you to know that you would be using tools like Helm and Customize to do your deployment. So those things are carried forward from the previous discussions that we have done thus far. So here what we are saying is auto deploy, no approval. In dev stage, there is no approval. So reads manifest.json. This is what will happen when the deployment will be done in the dev environment. The manifest will be read, and who is reading the manifest? It is your Jenkins server, your automation server that is doing this. It will read the manifest.json, deploy by digest, and perform smoke and health check whether the application is working fine or not. Health is your readiness and liveness probes. Smoke tests are whether you are able to access the application or perform basic functionality in the application or not. Second is, once this is successful, we are saying that we can deploy the same digest in the QA environment. But I want you to know that here, when will this be run? When there will be a promotion job plus approval. Now approval is, as I told before, it is optional, but typically you would see in staging stages there is approval. Your TL or your QA will be approving your request. So stage here is deploy same digest, perform integration, contract, API, UI plus performance security. And we have already discussed all these tests in our day one's lecture. And finally, so when you are deploying to the production cluster, there will be first be a promotion, and these things will be taken care by your Jenkins server itself. There will be two approvals. Your approvers could be your change manager, your TL, your application owner, and so on. So these are the steps that will be performed for deploying it to the prod environment. We'll be deploying the same digest again. That is the important piece. We are using the same artifact for deployment in multiple stages. Cautious rollout plus SLO guardrails, ready rollback. Now, if I want to summarize this, PRCI proves the merge, then the merge happened. Build once on main, promote that exact digest through dev stage prod with increasing confidence. I want you to know that if it was deployed in dev and that failed, I want you to know that merge has already happened. Then you must fix the problem in your main. Your developers must be equipped to fix this immediately, which is why when you are using this sort of design, your testing, your CI is very stringent. It takes care that everything is in place before the actual deployment takes place. But again, let's say if your application requires GPU, then you must ensure that in CI stage itself, you are polling your deployment environment to see whether those nodes are available or not. So you have to think like that. If you are adhering to this design, then testing must be extremely stringent. I hope you have understood this. And then finally, I want to discuss why and what of Jenkins. And I'll just read through these points because we have already understood these points throughout this lecture. Jenkins, why and what. What it is: open source automation server for CI and CD, runs pipelines as code from your repo. And we have seen all these things in action in our diagrams. Again, automation server, not just for CI CD, it can also do CT, it can do any automation that you want Jenkins to do. There are plethora of plugins available for Jenkins which can help you integrate various AWS, Azure, or GCP services, and you can leverage those. Why teams use it? Portable and extensible with rich plugins. Gates merges with green red status checks, fits GitFlow and trunk based workflows. We have just seen these. Enables build once, promote the same digest, and we have also seen this. How it usually runs, we will be discussing these things in detail, that what are the patterns that you can use for Jenkins, how Jenkins will scale when there are plethora of jobs running in parallel. So we'll see all these things. What it isn't: Jenkins is not a Git host, a registry, or a monitoring tool. It is an orchestration engine, it is an automation server. Alternatives and complements. Now, if you have a GitOps based workflow, then you will often see that Jenkins works in conjunction with your Argo CD, Flux, or your any other tooling similar to that. But there are alternatives to Jenkins like GitHub Actions, GitLab CI. That's all I wanted to cover. That wraps up day 2 of Jenkins Basics to Production course. Today we reviewed Git and branching essentials, decoded the continuous practices, compared GitFlow and trunk based strategies, walked the promotion flow from feature to dev to prod, and reinforced build once, promote by digest. You also saw how Jenkins orchestrates builds and promotions. In the next lecture, we'll install Jenkins and run our first pipeline. If you have any questions, feel free to ask them in the comment section and I will reply. If you have any questions, feel free to ask them in the comment section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.